Okie doke. 4.4. A firm can reduce emissions of a certain pollutant at the following costs. Blah, blah, blah. Assume that without pollution control, the firm would be emitting 10 tons. So emissions are 10 minus A, aren't they? Costs are 10 plus 2A squared or 0. Consider the case where the limit to polluting emissions, E, has been set equal to 8. And I guess this is the Altoona Environment Agency, monitors firms and controls may occur with royalty P if, after control, the firm is caught out of compliance, a fee F of E must be paid. The fee is structured as follows. With Q greater than 0, the fixed component, big Q, and little q, the proportional component. F of E equals Q E minus E bar plus Q. And of course, this only applies if the firm is non-compliant, otherwise you don't have to pay this Q. So how does the firm set its emission level? So, it's the usual kind of story. Again, as usual, we need to think carefully about setting up an optimization problem. Whose optimization problem is it in this case? It's the firm's. And as usual, because we've got this kind of abatement-y setup, it's all about costs, isn't it? So why don't we just go straight to costs and say, let's just assume for now an internal solution, but we need to bear in mind that this actual solution might not be internal, it might be a corner. Okay. So given an internal solution, we've got the firm costs are 10 plus 2A squared plus, and again, we're talking about expectations here, plus the probability P of getting inspected times the fee, which is Q E minus E bar plus big Q. Again, we're assuming an internal solution, so effectively we're assuming that the firm is going to cheat. And then we're going to compare the payoffs to the corner where it doesn't cheat. Okay. So I think this makes sense. But we've got an A here and an E here. But E is 10 minus A, isn't it? So how does the firm set its emissions levels? So why don't we replace A by 10 minus E? So the firm is trying to minimize, by choice of E, the expectation of C. First order condition gives us 40 times 10 minus E, go inside, we get a minus sign. Minus that, plus P times Q equals 0. When we shift things around, that's our first order condition, isn't it? And Q and Q are knowns, aren't they? That's like the levels of the finds, I think. Yeah. So we can solve for E. If we take this over, 40E is 400 minus PQ. So E is 10 minus PQ over 40. Quick pause. Okay. So, let's go back to the question. So we set up the problem, done some math. Now I need to go back and think about the question. And actually, what we need to do is determine the firm's emissions given these numbers. P is a half, Q is 8, so that's 4 over 40 is 0.1, so it's 9.9. Let me just check. Okay. Things went horribly wrong here. Who spotted my deliberate mistake? Must be more careful. So, this was the firm's cost minimization problem. What's the first order condition? It's 4 times 10 minus E minus. Okay. So then we get that, and E is 9. Okay. Now, we want to look at what the firm is actually going to choose. And because this is a kind of messy problem, it's not a nice convex problem. But basically, you just need to be aware that this, because of these fixed costs and stuff like that, which you can, because you can avoid these fixed costs if you don't abate at all, that is clearly making the problem kind of messy and adding the risk that you might have a corner solution. So we need to check the costs at the corners and at this optimum, internal optimum. So at the internal optimum, E is 9, A is 1, yeah? And so at the internal optimum, expected costs are 10 plus 2 is 12 plus a half. So that's 12 plus a half of Q. Q is 8. A half times Q times E minus E bar is 1, so E bar is 8, isn't it? E was 9. So that's a half times 8 plus big Q, which is 20. So that's 14. Sorry, 28, half of that is 14 plus 12 is 26. EC, when you're emitting 0, is 10 plus 2 times 10 squared, that's 210. Okay, that's not looking good, is it? And then, oh, no. If you're emitting 8, you're complying. You're complying when you emit 8. So then it's 10 plus 2 times 2 squared. 2 squared is 4, times 2 is 8, so that's 18. So actually, compliance costs are less than the optimal internal solution. But we also need to think, what are the expected costs of doing nothing? Because then, this whole thing is 0, we don't have this 10. So it's only the expected fine, which is a half times Q is 8, E minus E bar is 2, so that's 16 plus 20, 36, half of 36 is 18. So it turns out the firm is indifferent between complying or not doing anything. And this this solution is not good at all. Yeah, that is definitely not going to happen. Okie doke. Okay, so we're assuming there's this tougher limit and we need to rework these quantities, right? But I think this stuff still applies. Is this still right? We haven't put our 8 in here. So this was the first order condition. Let me think. No, because the E bar just didn't come into the first order condition. So this is still fine. But now we've got okay. Part B. The UEA reduces the emission limit to 4 tons. What happens with the same parameters? So for the internal solution, is still the same, but because P and Q haven't changed, P is a half, Q is 8, E is 9, A is 1. But now the actual expected costs have changed, haven't they? Because now we've got E is 9, 10 plus 2 is 12 plus a half times 8. But now this is 5. So that's 40 plus 20, I think, is 60, so that's 30. So that's 42, I think. Check my crib sheet. Yeah, the internal solution is 42. The cost of doing nothing goes up. So this is emissions 10. These costs are 0, but now we have a half times 8 times, 8 times 6 plus 20. 48, 68 times a half is 34. And the cost of complying E is 4 is now 10 minus 4 is 6 squared, 36, 72, 82, that's abatement costs, isn't it, to comply. comply, you're going to take on abatement costs of 82. Write that down over there, and then your expected fine is 0. Yeah. So the cost of complying is 82. The internal solution gives a cost of 42, but the corner solution with no abatement gives 34. You're going to go for the corner with no abatement whatsoever. And another pound. Okay, part C. If P is 1, what level do you set for the fine? Do you need a fixed charge? No, because of course, if P is 1, this is just the Pigovian tax, and you set the tax equal to marginal abatement costs. If you want to achieve emissions of 4 and abatement of 6, we should get 24,000 crowns per tonne. How am I doing for time? So where does that come from? Yeah, come on, let's do this properly. Come on. So the firm's problem then becomes this, doesn't it? Minimize cost through choice of E, and it's this. Yeah. So then the first order condition gives 4 times 10 minus E equals tau. And 10 minus E is 6, tau is 24. Yeah, okay, good. Oh, sorry, I missed the pause button, obviously. But the answer to question D is, well, yes, basically. I mean, it's pretty straightforward. You've still got imperfect monitoring and enforcement. The firm pays taxes according to the reported emissions. But then there's checks, and if you're shown to be misreporting, you're going to be fined, and so on. So it's basically creating a complex problem for the firm with sort of two parts to the problem. One of them is how much to abate, and the other one is what to report. And you could kind of have any solutions to that is kind of possible. So you could easily have, depending on what the fines are, what the probabilities are, etc., you could easily design a kind of setup where the firm chose the level of abatement that was equal to first best optimum that would be chosen by the social planner, but chose to report a higher level of abatement than that, taking a chance on not being checked and thus saving payments on that level of on the emissions. Okay, and that is the end of the uncertainty imperfect information questions, and we've just got game theory left.